In this video, we're going to find any x-intercepts that exist and the vertex of y is equal to negative x squared plus 4x minus 4. So starting with the x-intercept, anytime you want to find an x-intercept, which is a place where the function, like the graph of the function would run into the x-axis, anytime you want to find that, what you want to do is you want to replace your y value, or whatever your y is, any y's that you have, with 0 and solve for x. And so that's exactly what we're going to do here. We're going to replace our y with 0 and then solve for that x value. And that's going to tell us where this function, or where this, it is a function, but where this graph of this equation would run into the x-axis. And so putting 0 in the place of y is going to give us 0 instead of y is equal to negative x squared plus 4x minus 4. Now what we have is a quadratic equal to 0. And so what you may be thinking is, why don't we factor on the right-hand side and then use the zero product property, set each factor equal to 0 and solve. And if that's what you're thinking, that's exactly what you want to do. Now before we factor on the right-hand side, what I'm going to do to make the factoring a little bit easier is I'm going to multiply by negative 1. And of course, whatever we do on one side, we have to do on the other side. But it's really not going to change much on the left-hand side because 0 multiplied by anything is still going to give us 0. So we're going to have 0 on the left-hand side, and if we distribute the negative 1 to all of our terms on the right-hand side, a negative times a negative x squared is going to give us positive x squared, which that was the whole point of me multiplying by negative 1, is because I like for the leading coefficient, if I'm factoring a quadratic, to be positive. The negative 1 times positive 4x is going to give us negative 4x, and then the negative 1 times the negative 4 is going to give us positive 4. And so now that we have a positive coefficient on the x squared term, now we can factor more easily. If we factor the right-hand side, we're going to be given, or we're going to attain, x minus 2, x minus 2. Because negative 2 times negative 2 is going to give us a positive 4, and negative 2 combined with another negative 2 is going to give us a negative 4. So this time we don't have two distinct factors, we have the same factor twice, so it has a multiplicity of 2. And so all we have to do is set one of those equal to 0 and solve, because obviously you get the same thing both times. So putting x minus 2 equal to 0, if you add 2 to both sides, you get x is equal to 2. And so 2 is going to be the x value for our x-intercept in this case. In this case, we're only going to have 1. So we really want an ordered pair if we're looking for an x-intercept, but we know exactly what the y value is going to be because this is the place where you run into the x-axis. So if we plug 2 back into the original equation and mentally check it out, we know we're obviously going to get 0, because anytime you're on the x-axis, the y value is 0. So therefore, our x-intercept for this problem is going to be the point 2, 0. So we're halfway done. That's the first part solved. The second part of this problem asks us to find the vertex. Now the vertex, when we're given the quadratic in this form, where we can't easily pick out the vertex, that's where we're going to use our formula, the vertex formula, x is equal to negative b over 2a. So we need to pick out the a and the b just like we would do with the quadratic, like if we want to use the quadratic formula to solve this, and then we need to plug those in there, and that's going to give us our x value for our vertex. So our a is going to be the coefficient of the x squared term, and in this case a is going to be equal to negative 1, and our b is going to be the coefficient of the linear term. In this case b is going to be equal to positive 4. So now plugging this into our vertex formula, x is equal to negative b, so that's going to be negative 4, divided by 2 multiplied times a, so 2 multiplied by negative 1. And so now we can simplify. Negative 4 on top, 2 times negative 1 is going to give us negative 2 in the bottom. Negative 4 divided by negative 2 is going to give us positive 2. And so the x value for our vertex is going to be positive 2. What's interesting is if you're kind of clever in keeping up with what we did a minute ago, you can see that we have the exact same x value for our vertex as we do for the x-intercept that we found. So really you could go ahead and know that your y value is going to be 0 because it has to be the same point that we had for the x-intercept. But just in case it ended up being something different, I wanted to show you what to do. If you need your y value, which you do for the vertex, we want a corresponding y value, you would just figure that out by plugging this x value of 2 that we found into the original problem. And so let's do that, just like I said, just in case it ends up being something different in the future. I don't want you to always think it's going to be the same. So we're going to say y is equal to, we're going to put 2 in the place of x to find the corresponding y value to get the ordered pair. So negative 2 squared instead of negative x squared, plus 4 times 2 instead of x, minus 4. And our 2 squared is going to give us 4, so we'll have negative 4 plus 4 times 2 is going to give us 8 minus 4. And as you can see, negative 4 plus 8 minus 4 is indeed going to give us 0. So our vertex for this problem is going to be the ordered pair 2, 0. Now again, I want to stress the point that your x-intercepts and your vertex, they're not always going to be the same. So keep that in mind. Don't assume that's the case. This is just for this particular problem. Oftentimes you may have no x-intercepts when you solve. Sometimes you're going to have 2. So there are a lot of different cases when it comes to x-intercepts with the parabola, which is going to be the graph of our quadratic that we have here. So again, don't take for granted that these are the same. That's not always going to be the case.